Use the limit definition to find the derivative of a polynomial function. So let's take a look at our first example here. We would like to find the derivative of the following function using the limit definition. And we see the function we have here is f of x is equal to 5x squared plus 2x minus 7. So let's start off with the limit definition of a derivative. So we know here that f prime of x is going to be the limit as h approaches 0 of f of x plus h minus f of x all over h. I'm just going to quickly move this writing down because I wrote it a little bit too high. Alright, so now we just start filling in the items in our function. So for our first function, our input is x plus h, so we're going to replace all of our x's in the function with x plus h. So that's going to give us the limit as h approaches 0 of, let's see, 5 times x plus h squared plus 2 times x plus h minus 7. And then minus just our f of x function, which is 5x squared plus 2x minus 7. And that is all over h. Alright, so now eventually I'm going to have to multiply x plus h squared out, so I'm just going to quickly do that on the side to save a little bit of room here. So, x plus h squared. Remember, x plus h squared does not equal x squared plus h squared. Please do not fall into that trap. So, if it doesn't equal x squared plus h squared, what does it equal? Well, remember, a squared means we take the base and we multiply it by itself. So that's going to give us x plus h times x plus h. And then we can FOIL this out to get x squared plus xh plus xh plus h squared, giving us x squared plus 2xh plus h squared. So again, I'm going to substitute that into our limit in the next step. So we're going to have the limit as h approaches 0 of 5 times x squared plus 2xh plus h squared, and then plus 2 times x plus h minus 7, and then minus the quantity 5x squared plus 2x minus 7, and that's all going to be over h. And yes, these limit definition problems are a huge pain in the gluteus maximus because of all this crazy writing and all these steps, and yes, it is super painful. But, welcome to calculus. Alright, so let's continue working. So now we're going to distribute the 5 in, we're going to distribute the 2 in, and that's going to give us, let's see if I can squeeze that in here. It's going to give us 5x squared plus 10xh plus 5h squared plus 2x plus 2h minus 7. And then minus 5x squared plus 2x minus 7. Whoo, just snuck that in all over h. Alright, then next up, we're going to take the negative sign and we're going to distribute it into our f of x. And that's going to give us the limit as h approaches 0 of 5x squared plus 10xh plus 5h squared plus 2x plus 2h minus 7 minus 5x squared plus 2x minus 7 all over h. Then from here we can combine like terms. We can see that we have a 5x squared and a negative 5x squared, so those are gone. Get out of here, 5x squared. Let's see what else we have. And I realize I just made a boo-boo because I just said we were going to distribute the negative, but I actually didn't distribute to all the terms, so please don't make that same mistake. So this should really be negative 5x squared minus 2x and plus 7. So that means that this positive 7 and this negative 7 should go bye-bye. So that's out of here. And what else can we cancel? I can see that I have a positive 2x and a negative 2x, so adios 2x's. So then what does that leave us with? So continuing on, we're going to have the limit as h approaches 0 of 10xh plus 5h squared plus 2h all over h. Now, if we were to do direct substitution here, we would end up with 0 over 0, which means that we need to factor something out. And hopefully we can see that each of our terms in the numerator has an h in it, so that means that we can factor that h out, leaving us with the limit as x approaches 0 of h times the quantity 10x plus 5h plus 2, and that's all over h. Then, since we have a factor in the numerator and a factor in the denominator, those will cancel out, leaving us with the limit as h approaches 0 of 10x plus 5h plus 2. And now we can finally do direct substitution, so we can finally stop writing the limit. So we're going to substitute in 0 for h, which is going to leave us with a final derivative of 10x plus 2. Alright, so let's take a look at another example. Here we want to find the derivative of the function negative 3x squared minus 5x plus 1 using the limit definition. So, just like before, we'll start out with our limit definition, the limit as h approaches 0 of f of x plus h minus f of x all over h. And then we'll start substituting in, so we're going to get the limit as h approaches 0 of negative 3 times x plus h squared minus 5 times x plus h plus 1. And then minus f of x, which will be negative 3x squared minus 5x plus 1. And that's all going to be over h. Alright, so we see that we are going to have that x plus h squared term again in here. And based on what we did in the last slide, we can kind of use the formula here that x plus h squared is going to be x squared plus 2xh plus h squared. So we can just go ahead and jump right to that formula. So let's see, we're going to have the limit as h approaches 0 of negative 3 times x squared plus 2xh plus h squared minus 5 times x plus h plus 1 minus a negative 3x squared minus 5x plus 1. And that's all going to be over h. And then from here we can go ahead and we can distribute in. So we'll distribute the negative 3 to both terms, we'll distribute the negative 5 to both terms, and then we can even distribute this negative to all the terms, and this time I'm actually going to remember to distribute it to every single term, not just say it. So what are we going to get? So we're going to get negative 3x squared minus 6xh minus 3h squared minus 5x minus 5h plus 1 plus 3x squared plus 5x minus 1. And that's all going to be over h. And then from here we're going to see what can we cancel out. Well, we have a positive 1 and a negative 1, so those are gone. Let's see, we're going to have a negative 3x squared and a positive 3x squared, so those are gone. And anything else? Well, we have a positive 5x and a negative 5x, so those are also gone. And what does that leave us with? Well, let's see. We have the limit as h approaches 0 of negative 6hx minus 3h squared minus 5h all over h. And just like the previous example, every term in the numerator has an h in it, which means we can factor an h out of the numerator, giving us h times the quantity of negative 6x minus 3h minus 5 all over h. Then the factor of h in the numerator and denominator will cancel out, leaving us with the limit as h approaches 0 of negative 6x minus 3h minus 5. Then we can do direct substitution, so negative 6x minus 3 times 0 minus 5, which is going to leave us with negative 6x minus 5 as the derivative. Woo! Alright, so there we have it. The derivative, using the limit definition, is going to be negative 6x minus 5 of the original function, which is negative 3x squared minus 5x plus 1. Alright, so when you're actually doing these types of problems in Newton, some of these formulas will be useful to have in front of you. These are not formulas that you need to have memorized, because on the exam you will not be given any degrees of these powers, just because it takes way too much time. So again, these formulas are super useful, but they're going to be useful just for Newton. You don't need to memorize them. Now, we've already kind of derived the first one. We've already figured out that the quantity x plus h squared is equal to x squared plus 2xh plus h squared. X plus h quantity cubed can be simplified to x cubed plus 3x squared h plus 3xh squared plus h cubed. And then the last one you're going to need for the Newtons is x plus h to the fourth is equal to x to the fourth plus 4x cubed h plus 6x squared h squared plus 4xh cubed plus h to the fourth. And again, these are not formulas you need to have memorized for the exam. They're solely to help your life be a little bit easier when you do the Newtons. So let's take a look at one more example, and this example is 7x to the fourth minus 2x squared plus 5x minus 2. Alright, so let's start this one off with our limit definition. F prime of x is going to equal the limit as h approaches 0 of f of x plus h minus f of x all over h. And then we can do our substituting, giving us the limit as x approaches 0 of 7 times x plus h to the fourth minus 2 times x plus h squared plus 5 times x plus h minus 2, and then minus our function 7x to the fourth minus 2x squared plus 5x minus 2. And that's all going to be over h. Alright, well now here's where the real fun begins, because we have an x plus h to the fourth and an x plus h squared. So to help us out, we're going to be using our formulas. So we have the limit as x approaches 8, and we're going to have 7 times x plus h to the fourth, get ready, x to the fourth plus 4x cubed h plus 6x squared h squared plus 4xh squared plus h to the fourth. Then minus 2 times x plus h squared we know is x squared plus 2xh plus h squared plus 5 times x plus h minus 2. And then minus our function 7x to the fourth minus 2x squared plus 5x minus 2. And this entire monster is all over h. So, whew, let's keep rocking. So then we need to distribute everything that we can into everything else that we can. Lots of distributing here. And let's do it, because once we distribute, then we can cancel. So the limit as h approaches 0 is going to be 7x to the fourth plus 28x cubed h plus 42x squared h squared plus 28x h squared plus 7h to the fourth minus 2x squared minus 4x h minus 2h squared plus 5x plus 5h minus 2 minus 7x to the fourth plus 2x squared minus 5x plus 2 all over h. Woo, isn't this fun? However, this next step is because now is where we can cancel things out. Because we can see that we have a positive 2 and a negative 2. So they go away. We can see that we have a negative 5x and a positive 5x. So those would also go away. Then we have a positive 2x squared and a negative 2x squared. So those would, yes, you guessed it, go away. Then a negative 7x to the fourth and a positive 7x to the fourth. So let's get rid of those two. Alright, so what does that leave us with? Well, still a bunch. So let's see, we're going to have 28x cubed h plus 42x squared h squared plus 28xh squared plus 7h to the fourth minus 4xh minus 2h squared plus 5h all over h. All right. Whew. So what do we do next? Well, if we notice, every term that's left has an h in it. So just like with the previous examples, we can continue to factor out that h. And if you notice, this is going to become a pattern. Alright, so now that we have factored out one of the h's, we can cancel that factor out in the numerator and denominator. And it's going to leave us with the limit, as h approaches 0, of 28x cubed plus 42x squared h plus 28xh. I'm not going to be able to fit it in here. I need to make a little bit of room, so hang on for a second. Alright, so we're just going to continue on a new page. So again, we're going to have limit as h approaches 0 of 28x cubed plus 42x squared plus 42x squared h plus 28xh plus 7h cubed minus 4x minus 2h plus 5. Alright, so now we can do direct substitution. So we're going to get 28x cubed plus 42x squared times 0 plus 28x times 0 plus 7 times 0 cubed minus 4x minus 2h plus 5. And then anything that has a multiple of 0 is going to cancel out. Oh, and I forgot a 0. There should be 2 times 0 there. Let me rewrite that for you. But that doesn't matter because that term is going away. So what does that leave us with? Oh, that's going to leave us with a final derivative of 28x cubed minus 4x plus 5. Alright, folks, and that is it. That is using the limit definition to find the derivative of a polynomial function.